All right, 3.5, number 12. So looking at 3.5, number 12, uh, let me fix this real quick. It's not f of x, it's f of t. So let's fix that first. There we go. So first of all, I'm looking at this. F of t equals negative t squared plus 4t minus 3 from 0 to 5. And we want to graph the position function, find and graph the velocity function. When is the object stationary, moving to the right, moving to the left. Determine the velocity and acceleration of the object at time t equals 1, and determine the acceleration of the object when the velocity is 0. All right, so first of all, we can also say if this is the position function, then we know that the velocity function is actually equal to the first derivative. So in this case, it's negative 2t plus 4. So this is the velocity function. We can also say that the acceleration function is f double prime of t. And f double prime of t would be first derivative being this, and second derivative being the derivative of this. So in this case, the second derivative of well, this just becomes a constant negative 2 is all it does. So now we have velocity and acceleration functions is what we have. So the next thing we would want to do is get some graphing of this guy done. So let's go into Desmos. Is where I would go first. Hopefully you guys are trying this at home. You're doing the same exact thing. Go into Desmos and I want to graph negative t squared. So I write y equals negative t squared, and that's plus 4t minus 3. Plus 4t minus 3. So this will be your position function right here. And then if we want to graph the derivative of that, or the velocity function, that'll be negative 2t plus 4. So there's your velocity function. One of the ways that you know you have this right is you'll notice that your velocity is positive. This whole region shaded. You know, if it's all bigger than 0, the whole blue line is bigger than 0, the velocity is positive from 0 to 2. You'll notice this critical point where the tangent line would be 0, that actually represents the point when the velocity is, let's say, negative. So from 0 to 2, we would be going right, and from 2 to 5 and so on, we would be going left. Or if this was a rock being thrown up in the air, we'd say that we're going up until we reach time 2, and then we're going down beyond that. So both of those could be used to answer kind of the A and B. So A and B is to find the position function, and we've graphed the position function right there, or graph the position function. And B is to find and graph the velocity function. We found the velocity function was the first derivative, and we graphed the velocity function there. Determine moving right, moving left. We've done that. Now we want to determine the velocity and acceleration of the object at time t equals 1. So that's part C. So at time t equals 1, what is the velocity and acceleration? Well, the good news is we know that the velocity is the first derivative. So the velocity at time 1, if this is time 1, it's going to be equal to first derivative at time 1. So that just means I'm going to plug in a 1. So it's negative 2 times 1 plus 4. So the velocity at time 1 is negative 2 plus 4, which is 2. Unsure what the units were here. You know, typically there'll be things like feet per second or miles per hour or something like that. The acceleration at time 1 then, this one's a little, excuse me, let's see here. Yeah, the velocity and acceleration of the object at time t equals 1. So in this case, the acceleration of this object at time t equals 1 would be f double prime of 1. Well, the unfortunate thing here is that for all, the acceleration is negative 2. So negative 2 is going to be your acceleration. And then finally, in part D here, determine the acceleration of the object when the velocity is 0. So we need to first determine when the velocity is 0. And the way we do that is we take the, what we do is we take the velocity and we set it equal to 0. So this is our velocity function now. v. So we say, well, what t is going to give me 0? So I take negative 2t plus 4, and I'm going to set that equal to 0. And so in this case, I'm going to get, let's see, 4 equals 2t, and I get t equals 2 seconds. So at time 2 is when the velocity is going to be 0. That's what that represents. But remember what D was asking us: determine the acceleration of the object when its velocity is 0. So this is when the velocity is 0. This is when v equals 0. But we want to determine the acceleration at that time. So we're going to take f double prime of 2. Well, and the sad thing here too is that this is a constant, so it doesn't really matter in this particular problem. It's still going to be 2. So that answer is 3.5, number 12.